Alright, so now let us look at this example here. If we have a family has n children, okay, so n is greater or equal than 2. What is the probability that all children are girls, given that at least one of them is a girl? Okay, so we can think about it into this way. First of all, we can think about it, the sample space as denoted as S, okay? And then you see you can have, I don't know, like girls, all girls, right? Or there is maybe the first one is a boy, and then girl, etc., right? Until to the very end, you're gonna have boys. Okay. So in other words, each one you can have two choices: boy or girl, boy and girl. So you're gonna have 2 to the power n elements inside of this one. And clearly, this is a conditional probability. If we set the event A is all girls, okay. All girls. That is, it's gonna be the element. Right? So this is the event A. And B, and we know that the probability of this, of A, is going to be 1 out of 2 to the power n. Okay, so we know that pieces. And moving on, we're trying to know that, okay, what is the, given that at least one of them is a girl. So let's see if we want B as the event is at least one is a girl. Now when you have the terminology at least, noticing that to figure out its complement is way better, which the complement is no one's girl, right? So it's all boys, right? So it's gonna be, it's all boys. So the probability of B complement is also 1 over 2 to the power n, okay? And hence, the probability of B is just a 1 minus 2 to the power of n, okay? So the problem that we are looking for, it is, what is the probability of having all girls, given that we already know one of the, given that at least one of them is a girl. So this is a conditional probability, and we know that it equals a probability of A intersect B over the probability of B. Well, if you look at what is the intersection between A and B, so you see A is the event is all girls, B is the event is at least one is a girl. Do you agree that the A intersect B, it's event A, right? It's all girls. So put every pieces together, you see the probability of A intersect B is the probability of A over the probability of B. So we know both. So it's 1 over 2 to the power of n over 1 minus 1 over 2 to the power of n. And I believe if you multiply 2 to the power n on the top and bottom, so you're going to have 1 over 2 to the power n minus 1, right? So I think that's how do we explain this problem. Okay.